All right, in this lesson today, kids, we are going to go over understanding rates, topic 110.1. A couple things I want to point out to you is that rates, the reason we learn this is rates help us to make good decisions about amounts. And those amounts could be many, many different things, but they basically pull together different numbers and tell us how those numbers relate. Unit rates, such as miles per gallon or ounces per pound, are important because we can then determine a better deal. So those are some practical looks at why we need to understand rates and what rates mean. They help us make good decisions and they help us save money. Okay? Now, in the Pearson book, which is a fantastic product, a good book, and you guys have that with you, you should be opened up to topic 10.1 right now. If not, pause the video and open up to that lesson. Now, in the book, they talk about understanding rates, okay? Are there special types of ratios? Yes, there are. And one of those special types of ratios is a rate. A rate is a special type of ratio that compares quantities with unlike units of measure. And that's the important part of this definition, is the fact that a rate is a comparison, a ratio, of unlike units of measure. Okay, miles per gallon, pounds per minute. Okay, that sort of information. And then they give us an example, such as 150 miles to 3 hours. Okay? So a rate is a special type of ratio that compares quantities with unlike units of measure, such as 150 miles to 3 hours. If the comparison is to 1 unit, the rate is called a unit rate, such as 50 miles to an hour. And notice how you have 1 hour, but you're still comparing miles to hours. And up here you have 3 hours, and you're comparing 150 miles to 3 hours. So the difference is you have a rate, which is a comparison of unlike units of measure, but a unit rate is a comparison such as 50 to 1. Okay? And so they give us a situation and they say if the comparison is to 1 unit, the rate is called a unit rate, such as 50 miles to 1 hour. Find how far the car travels in 1 minute. Okay? So what they're referring to is this car right here. And it is traveling at a rate of 7 kilometers in 4 minutes. So what you have there is you have 7 kilometers to 4 minutes. Now, if we want to find a unit rate, what you want to do is set this up and write it as a fractional amount. If you write it as a fractional amount, that means you're going to have to read it 7 to 4. Okay? So if you want to create a unit rate, it's always best to set up your ratio as a fraction. Okay? And that'll make things much easier because we want to find out how far the car will travel in 1 minute. Alright? So we set up our ratio like this so that we can create an equivalent amount. Alright? So the book then goes on to say that first, write how fast the car travels as a rate. Well, 7 kilometers in 4 minutes. Notice how they set it up as a fraction so it's easy to deal with. And then they say to find the unit rate, divide the first term by the second term. Now remember that when you look at a ratio such as this, you actually can treat it not only as a ratio, but it is also, you can treat it as a fraction, and it is also an expression, and it is an expression about division. So all of these can be treated the same through the process of division, which they show up here. Divide 7 kilometers by 4 minutes. All right? And when you do that division, you can see that 4 goes into 7 one time, and they do the division, and they come out with an answer of 1.75, or 1 75 hundredths. Now, to understand why it works, okay, remember that you can divide the terms of any ratio by the same number to find an equal ratio. So in other words, we go back to creating equivalent amounts. In other words, we take our 7-to-4 ratio and we want to create an equivalent ratio. We know that we would want 1 unit down here, so we would use the operation of division. And then we know that if we want to go from 4 to 1, we're going to divide it by itself. And then we would have 7 divided by 4, which, they did the math already, gives us 1 75 hundredths. So the unit rate is 1 75 hundredths of a kilometer per minute. The car can go 1 75 hundredths kilometers in 1 minute. Okay? And so that's basically what this lesson is all about. It is all about remembering that you can take a ratio, you can divide, and you can find a unit rate and compare it to just 1. Okay? Alright, let's take a look at our example that we did in class. Okay? And if you were in class today for this lesson, you would see that we did an activity with the K'NEX, okay? And the K'NEX coaster parts sorting rates. And what we did was we all got a number of pounds and ounces to start with. 3 pounds, 8 ounces, 3 pounds, 5 ounces, 2 pounds, 15 ounces, and we had different groups, group 1, group 2, group 3. And then what we did was we sorted them, okay? And then we decided that we wanted to find out which group was going fastest, and we would need a rate per minute, pounds per minute. All right? So what we did was we went ahead and we first converted our pounds and ounces to straight ounces, okay? And we know that we have 56 ounces because we have 3 times 16 plus the 8 ounces would give us that amount, because there are 16 ounces in a pound. So once we did that, we converted each to ounces, We then sorted those parts and we got a time. And this time was in minutes. So we have our time in minutes for each group. Okay? Now remember, we wanted to find out which group was sorting the fastest, which means we're now going to have to take this information, the number of ounces in this minute, number of minutes, and we're going to write it as a ratio. 56 to 9. So 56 ounces in 9 minutes. Then we did the next one, and we had 53 ounces in 8 minutes. And then we had 47 ounces in 8 minutes. Now we still want to know who is the fastest, but in order to figure out who the fastest is, we need to break these down into a unit rate, okay? And what we want to do is make that unit rate ounces per minute. So in order to do that, we have to do the division, okay? And so when we do the division, we were allowed to use calculators. And we bring up our calculator. and we clear it out. And we can see that if we take 56 to 9 and we divide, we will get our unit rate. And so we come over to our calculator and we take 56 divided by 9 and we get 6.2 repeating, and we're going to round that to the nearest tenth, so it'll be 6 2/10 to 1. So this team did 6 2/10 ounces per minute, okay, which is a pretty good unit rate, okay, it's a pretty good unit rate. And so now we'd want to check the other one and see what its unit rate is. So again, we would take 53 to 8, and we would divide it by 8, and of course we get a unit of 1, and then we take 53 divided by 8 equals, now we get 6 625 thousandths, so we're going to round that again to the nearest tenth, which would be 6 2/10 to 1. So you can see that these are very close, but because we rounded, you can see that we actually have a little bit of difference. Oops, a little bit of difference. 6, wrote my ratio wrong there. 6.6 to 1. There we go. Caught that. Good thing I caught it. And you would see that when we do that, we have a little bit better rate going on there, okay, because they're doing a few more parts than the other group. Well, our last one to check would then be 47 to 8, and again, if we did the division, okay, which is the same as treating it as a division expression, okay, you would find, if you use your calculator, you would take 47 divided by 8, and you get 5, and if we round it to the nearest tenth, we would get 5 9/10 to 1, okay? And so now we could compare and we did compare which group was the fastest, and we could see that this group only had 5 ounces, okay, as a whole number. This group did 6, and this group did 6. So this group did not do very well. They went quite slow compared to the other. Well, not quite slow. They went slower. This group has 6 in the 10th place, so it is the greatest, and this group would then be in the middle. So then we can determine that this unit rate was a better and faster unit rate. Okay? So anyways, that's what we did in class with our little quick hands-on lab. So let's go back to our book and take a look at some of the practice problems. Okay? Let's take a look at these practice problems and see if you can solve them. So why don't you pause the video and see if you can come up with the answers. All right, here we go, kids. Let's take a look and see what the answers are. Okay? Write each as a unit, as a rate, and as a unit rate. Okay, so the first one would be as a rate, it would be 60 kilometers in 12 hours. As a unit rate, it would be 5 kilometers in 1 hour. Okay? Next, we would have 26 centimeters in 13 seconds, and the unit rate would be 2 centimeters in 1 second. And again, it is just a matter of dividing by 13 to get your answer. The next one would be 230 miles on 10 gallons. Miles per gallon is important. As a rate, it is 230 miles to 10 gallons. But if we were to divide 230 by 10 to come up with an equivalent unit rate, we would have 23 miles to a gallon. And then our last one, number 4, we have $12.50 for 5 pounds. The unit rate would be $2.50 for 1 pound. So our initial rate would be $12.50 to 5 pounds, and our unit rate would be $2.50 per pound. All right? Okay, one more problem. Let's see if you can solve number 23 on the other page. Pause the video and come up with your answer. All right, here's our answer. Misha buys 4 tickets to a soccer game. The total cost before taxes is $90. Which equation would you use to determine the price P of each ticket? Well, in this case, a lot of kids would think, okay, my ratio, okay, is I can get 4 tickets for $90. So it's $90 for the 4 tickets, and that's important. And so then you can divide to figure it out, a unit price, all right? So very easily, you could divide to figure out this price, but remember, your division is coming to figure out a unit price, okay? And the unknown amount is this up here. And so what you want to remember is that in this case, it is actually a multiplication situation. And it is 4 times some unknown amount, which equals 90. And so what you're getting is you're getting a rate of 4 tickets for $90, or $90 for 4 tickets. Okay, so it's a 90 to 4. And so in order to undo this situation, you would have to use division. But over here, we don't have a situation where you have the price being set up to give you the correct amount. So in other words, this might work, but if you plug 90 in there and divide it by 4, that doesn't give you 90. So this would not be a viable answer. This wouldn't be an answer either because it doesn't involve multiplication or division. But in this case, you'd think, well, maybe this would work. But again, it's not going to give you an accurate amount. 90 times an unknown amount won't give you the $4. So this right there is the equation you want to use, because this equation sets you up for the inverse operation to give you the answer. Okay? And again, that goes back to being very careful about what we read and figuring out exactly what they're asking and what type of situation it is. All right? So hopefully this video helped you out. If you're still a little confused, you can use the Pearson-Fox video to help you out as well.
Mm-hmm.